Hey everyone, and welcome to this explainer. I am absolutely thrilled to guide you through today's masterclass. We're going to be exploring a seriously fascinating intersection today. We are combining the raw, calculating power of 3D geometry with the deep wisdom you actually need to use it properly in the real world. So let's dive right in. We're going to see how understanding physical space can actually teach us a whole lot about our own personal dimensions. Okay, picture this. You're an engineer or a project manager on a massive construction site, and you're faced with this exact dilemma. If a sphere and a cylinder are the exact same size, meaning they take up the exact same basic physical footprint with matching radii and heights, which one holds more? It kind of sounds like a trick question, doesn't it? Instinctively, you might think, well, they hold the same amount, or maybe the sphere just looks a bit more spacious. But guessing in the real world, that costs money. We need mathematical certainty.
So here is the absolutely crucial point. Analyzing and choosing the right solution path is way more than just some classroom exercise. The big idea we're looking at is that knowing exactly which shape holds more and understanding how these volume formulas relate to each other directly saves time and money. In the real world, whether you're managing construction materials, running complex scientific experiments, or just trying to keep a super tight budget, choosing the best formula is literally just as important as knowing the formula itself.
Section 1. The power of volume. Let's look at efficiency in reality.
So why do these volume formulas actually matter so much? Well, let's look at how this math translates to real-world efficiency. Think about construction. If you need to pour concrete into a mold, overestimating your volume wastes really expensive materials. But underestimating, that can literally ruin the structural integrity of a building. In science, dealing with pressurized gases or chemical mixtures means you need incredibly precise volumetric containers. And of course, all of this circles right back to budgeting accurately. It's never just about plugging numbers into a calculator, it's about analyzing the physical world so you can make the absolute smartest choice.
Moving on to Section 2. Sphere versus cylinder. A true heavyweight showdown.
Let's look a little closer at the mechanics here. Say you have a sphere and a cylinder, and they share the exact same radius and height. The golden rule here is that the volume of the sphere is always going to be less than the cylinder's. But why is that? Well, just notice the formula for the sphere. It relies on a 4/3 factor and a cubed exponent for the radius. Now look over at the cylinder. It uses totally different multipliers, specifically squaring the radius and then multiplying by the full height. Because of that 4/3 factor and the way those exponents behave, the sphere just physically can't catch up to the cylinder's capacity when their outer dimensions are exactly the same. Let's put some actual numbers to this to see it in action. In this first example, we're comparing a sphere and a cylinder, where the radius is 3 centimeters and the height is 6 centimeters. When we crunch the numbers, the sphere's volume comes out to roughly 113.10 cubic centimeters. But the cylinder? It reaches approximately 169.65. The math doesn't lie, and this side-by-side comparison proves it beautifully. The cylinder holds significantly more volume. All right, Section 3, the Sand Container Challenge. Let's try a practical scenario. I want you to treat this like a real-world puzzle for a second. You've been tasked with storing a massive amount of sand, and you have to choose between two available containers, a cone or a sphere. Both of them have a radius of exactly 4. Take a quick second and think about it. Which one are you going to choose to maximize your storage? Do you have your guess locked in? Okay, let's see if you were right. Just look at this staggering difference. With a radius of 4, the cone gives us a volume of approximately 67.03. But the sphere? It absolutely dominates with a volume of roughly 268.08. Honestly, if you chose the cone, you'd be making way more trips to haul all that sand. The sphere is the clear, undisputed winner here, holding drastically more volume for the exact same radius. Let's look at one more quick comparison just to really cement this pattern in our minds. Here we have a cone with a radius of 2 and a height of 5, going head-to-head against a sphere that also has a radius of 2. Now, even with the cone stretching all the way up to a height of 5, its volume is still only about 20.94. The sphere, relying purely on that radius of 2, still comes out way ahead at 33.51. Once you start seeing these patterns, analyzing shapes becomes total second nature. Section 4, Rank the Shapes. Time for some interactive homework. Let's think through a few more matchups using the principles we've just been talking about. First scenario, who wins between a sphere and a cylinder with a radius of 4 and a height of 8? Well, based on our very first rule, the cylinder easily takes the crown. What about the next one? A cone versus a sphere, both with a radius of 3. We know from our sand challenge exactly how that one plays out. And finally, a sphere with a radius of 5 versus a cylinder with a radius of 5 and height of 5. I highly, highly encourage you to pause for a second, jot down the formulas, and rank these for yourself. Doing it yourself is for sure the best way to make this knowledge stick.
Before we completely leave the math behind, here's a final spatial awareness prompt for you. Let's flip the script and think inversely for a moment. If your goal wasn't to hold the absolute most material, but rather to save physical space on a really crowded shelf, would a cone or a sphere be better? And why? It forces you to stop and think about the physical footprint versus the internal volume, which is a brilliant way to test your true grasp of 3D geometry. And now, Section 5, Education Needs Morality. So the source material actually makes a really profound pivot here. To understand it, we need to look at the philosophy behind the HeroesmartAcademy Godly Learners series, which is the foundation of the source text we're analyzing today. Their core philosophy is all about intertwining biblical morality directly with education. They make the case that teaching someone how to calculate volume or how to engineer a skyscraper is essentially incomplete if you don't also teach them the moral framework of how to live and operate ethically in the world. Listen to this specific quote from the source. "Education without morality will hurt. What's the point of being smart and supposedly educated and continuing to make bad choices that hurt?" It's a pretty powerful reflection, right? The authors are arguing that you could be the most brilliant mathematician or architect on the planet. You could know exactly whether to use a sphere or a cylinder to save thousands of dollars on a project. But if you lack a moral compass to make good choices in life, that raw intelligence can actually lead to destructive outcomes. From their perspective, knowledge is really just a tool, and morality is the hand that has to guide it. The source material anchors this whole philosophy in a specific biblical promise found in Romans 8:67. This text promises peace of mind to everyone who keeps their minds spiritual. The overarching idea presented here is that pairing hard academic skills, like mastering those complex volumetric formulas, with spiritual mindfulness leads to vastly better overall life choices. When you engage with your education through a moral lens, the ultimate result isn't just becoming smarter, it's finding true peace of mind. And that brings us to the core takeaway of this explainer. We started out deep in the hard numbers of geometry, figuring out how to manipulate space and volume to our absolute advantage. But as we've seen through the source material, those equations are really only half the journey. So I want to leave you with this final lingering thought from the authors. You now have the formulas to build a world, but do you have the wisdom to build it right? Thank you so much for joining me on this explainer. Keep learning, keep growing, and I will see you next time.